Chandler, you can begin now.
Okay. Yeah. All right. So thank you everyone for coming out to the lecture tonight. Before we get started, I do want to mention next week, February 22nd, we have Tatiana Bilbao going to be lecturing particularly on the project that she's master planning here in St. Louis. So that'll be exciting. Please tune in for that. For this evening, this is the first visiting faculty workshop for Fox Friday. And so we're kind of happy we're starting this with Brian. So the workshop is tomorrow. So we highly encourage, if you haven't signed up, go ahead and try and sign up for that tomorrow. It's going to be a really great workshop. So Brian's work crosses over between art, design, and architecture, which really makes him ideal for the first of the Fox Friday workshops. We're inviting somebody into campus. His work is kind of blurring between computational design, visual representation, and kind of speculation on materials. Brian is a visiting assistant professor at the College of Design, University of Kentucky. And his research uses advanced modeling and representation experiments as a way to inform his architectural processes and vice versa. So his processes include a whole kind of series of software and techniques. Ultimately, he's kind of exploring field conditions, sometimes inexact repetition of lines or objects, sometimes singular fields, other times overlapping fields that allow new figures to be revealed. But often is using various combinatory processes, meaning that kind of combining dissimilar types of parts to form new wholes. All the while kind of speculating on materials, exploring atmospheric conditions and mood and lighting effects, which produces things that are kind of simultaneously familiar, yet also a little bit strange, which kind of really draws you in to his works. Also, he's using dynamics. So, kinetics and motion as a way of revealing the relationship between parts, speculating on the behavior of materials. His work has been exhibited at the 5th International Architecture Biennale in Rotterdam. And he also comes with some really great practice experience, including architectural practices such as Morphosis Architects, Bernard Tschumi Architects, Hollwich Kushner, and Lang Architects. With that, we welcome Brian Richter.
Thank you so much, Chandler. I appreciate it. It was a really great review of the work. We've never talked about it. I think it's great to hear what you think about it. But thanks everybody for joining this evening. I'm glad to have made it to St. Louis. The weather was quite a doozy coming over here from Kentucky, but glad to see that we're all sort of hunkered in. But so as Chandler mentioned, my work really does stem from a really deep interest in visual culture generally. And we'll be looking at a range of work, or more or less a range of projects that I've been working on over the past 2 years. generally studies. Some are actually specific projects, but most of them are studies that focus on, again, an echo that my interests architecturally and design in general. So I've titled this talk after the workshop. So it's more of a synthesis between what we'll be doing in the workshop and what I've been investigating myself in my research at the University of Kentucky. So jumping in here, let's see if we can get started. I'm gonna begin this a little bit more free and a little bit less specific in terms of trajectory of these ideas, but much more focusing on these things as categories that sort of drive the work as I see it, evolving from a very specific place from an architectural standing. So I've sort of begun with what I like to say or call as design systems and motion graphics. And motion graphics, of course, has been a really significant interest for me ever since undergraduate school, when I got into, of course, specific softwares and learned how to manipulate and sort of have full control over specific content within the digital realm. So pairing those ideas with design systems, architectural systems, et cetera, really are the jumping point for all this body of work that we'll be looking at here shortly. So stemming from that deep interest of motion graphics and things of that nature, my interest also lies, again, in architectural visualization, not necessarily as representation for representation's sake, but much more as an integral part of the design process and how these things sort of fold in on one another to sort of enhance the design concepts themselves, but also then play up the opportunities within that realm to really start to challenge a lot of the things that we talk about in not only an academic context, but in a practical context as well. These three introductory animations are much more a broad spectrum of the things that I've been investigating in the context of motion graphics that will start to get a bit more specific as we go through the presentation. Ideas of texture and relationships between similar and dissimilar systems, of course, within the context of a design platform, but also, again, a bit, as Chandler mentioned, a bit speculative in terms of the way that we can start to think about things like particle systems as shape, sort of form shaping and space shaping elements. And then, of course, dealing with much more specific architectural conditions in the case of the diagram on the right, where assembly and tectonics become, again, much more specific and important for me as an architectural thinker. So a lot of these things, again, are focused or rooted on tectonic relationships, again, in architectural language. But again, we can think about these things much more general and much less specific in that context, considering that there are a lot of overlaps within different design methodologies and practices. So this series here, we start to get a little bit more specific with the way that we're manipulating geometry in a real-time context, using animation as a technique to sort of test variation across that broad spectrum. And of course, all under the lens or under the microscope of actually creating architectural conditions or architectural space that then can become much more tangible and much more of a snapshot of these conditions in the built environment. So drawing, of course, becomes a pretty significant thing. We'll talk about that in just a little bit. But in the case of these elements, of these animations, drawing is always, of course, an implication in the process of the work, in the sense that drawing is more or less a process of actually creating sort of two-dimensional conditions, but now looking at them in three-dimensional animated conditions starts to get a little bit more interesting in terms of the possibilities of these systems and how they evolve into much more specific architectural conditions here. So these diagrammatic architectural studies, again, with focus on tectonics, started about 2 years ago. And right at the beginning of this process, I was sort of getting into the real-time realm, real-time representation or animation in the context of this design process. And we see here that there are a couple instances of direct connections back to what architectural representation might seem as the default in terms of a fixed image or a fixed condition within the context of a three-dimensional project in any given space. So I'm trying to get to a position where we're actually pushing on those conventions and starting to see how we can use animation and motion graphics and sort of animated conditions to get into a much more specific realm in architectural thinking. So drawing and animation, this series here, we look at certain conditions in the realm of any given 3D software. In this case, I'll talk about Maya a little bit. We'll talk about these things in the workshop as well. But I'm really investigating tectonics in space and merging particle systems with flexible rigid geometries to generate spatial conditions that are ever changing. So each one of these individual images are exactly that, in the sense that they're three-dimensional compositions that have interactivity with one another, that are all sort of pushing against one another in a physical sense to gain a pretty good understanding of how these things operate in their context, but then also have very specific, what I like to say is a sort of a freeze frame or a snapshot of these conditions in that range of animation, to sort of look at these things as isolated architectural conditions with materiality, composition, etc., formal qualities, assembly, layering, relationships, etc. So these tectonics are more or less the merging of these particle systems with flexible and rigid geometries to generate spatial conditions. And then again, the translation of the interactive design systems into what might be a speculative built space is really what I was investigating here early on, evaluating scale, relationships, again, those material adjacencies, starting to deal with lighting, tectonic relationships through material translations, adjacencies, connections, etc. And then, of course, atmosphere and experience, and how spatial formal conditions affect the experience as either a fixed or animated intervention. So beyond that, the articulation of the passage of time is something that I've been interested in the context of these studies. And if we go to the next slide here, if I can. So zooming in a little bit on these individual studies, the passage of time is something that was pretty interesting in the sense of this workflow. Are we still going? My Zoom is hopping in and out. Can you guys still hear me?
Yeah, we can hear you fine.
Sorry, Chandler. Okay, so let's see, where was I? Yeah, Anthony, I think we're good. So again, the atmosphere and the experience of these are sort of at the forefront of the studies themselves, but then again, looking much more specifically at the way that materials, geometries, etc., have a relationship to one another in sort of an abstract context without any specific position in a given site or context. So these studies get a bit more specific in that sense. And of course, if we go through and look at some of these in much more detail, these again are all snapshots of these specific studies and sort of dealing with these things in real time. In a sense, these are all renderings as opposed to them being drawings or sort of representations of drawings. So these are all three-dimensional conditions or compositions within, again, an abstract realm that deal with these things of architectural principles that I've talked about a little bit, specifically about how light has an impact on the reflectivity of surfaces, but then how certain things might have a certain legibility given a certain camera angle. So a lot of these things are starting to get much more specific in terms of enclosure or envelope or things that are rooted in architectural conditions, but not necessarily looking at them as just renderings. I still do consider them as drawings in the sense that they are a simulation of time across any given spectrum in the case of one of these specific studies. So just looking a little bit more into how particle systems can work with rigid geometries, in the sense that nucleus and dynamics in Maya can start to generate many iterations in a very short and compressed amount of time, but then also dealing with conceptual notions of hierarchy of form, space, shape, etc. So sort of the tail end of this small series was a sort of the culmination of these things in a much more neutral sense, and the way that individual geometries are then replicated to make much more, again, of field conditions. But the introduction of sort of real life camera constraints really sort of changed the work and the way that the work was being investigated from my point of view, in the sense that the realization of a physical camera or physical based camera has a completely different implication on how the geometry is legible in any given frame. So the work becomes a bit more focused, but also the idea is to sort of get a little bit more obscure, or not necessarily show clarity always, but there's a bit of ambiguity here within this context. So although all these previous examples are rooted in architectural concept, of course, architectural specificity is prioritized with these next elements, or these next studies, in the sense that material specificity, formal specificity, relationships of geometry types, spacing, combination of forms, overlapping of materials, etc., front and back, being really significant and really important in the way that I'm evaluating these geometries, and starting to deal with a notion of interior exterior in a much more abstract sense as well, given that they're sort of presented as objects. So the objectness is simply a result of these being more or less snapshots or vignettes of ideas that could then again be deployed across many different levels of architectural conditions. And then also getting into a much more flexible landscaping condition with atlases and sort of generating our own individual three-dimensional plants or elements that then get combined into that particle system assembly logic that we've talked about a little bit before. So some detailed shots of that, and how we can start to think about these different material languages to start actually playing with these tectonic relationships in a much more contrasting sense of hard and soft, or sort of playing with the juxtaposition of hard and soft, or sort of a layering or a very clear legibility between layers, given that there's a lot of depth in some of these, but all working with very similar system. It's just a matter of the parameters that are involved and starting to change for maximum variability across these systems. And then finally, the material specificity sort of ties together the previous example of starting to use physical based cameras to sort of understand how surface texture can be completely controlled in the context of a specific piece of geometry, so that it's not necessarily a result of the software, but we're fully in control over how these things are starting to be designed or considered at a very small level of detail, and of course sort of growing out of that as well. So next, this next little category again is more to do with what I'm calling digital economy, which is the integration for me of real-time platforms in the context of these design studies. And real-time platforms again are allowing me to, and allowing us as designers and sort of creative thinkers to really challenge a lot of these notions in a much quicker span, or think about these things as iterations that aren't necessarily locked into or not necessarily constrained by time, because a lot of these decisions can be really quickly evaluated and then of course fed back into this design loop that I mentioned in a little bit just a minute ago. So in the case of these three videos, I've started to use particle systems as deformers. So starting to think about envelope and enclosure in the context of architecture, that essentially starts to contradict material language in the sense that in the case of these are galvanized metal surfaces that are then completely manipulated by a massless particle system in real time. So starting to think about the opportunity of having building elements or sort of elements of enclosure, as we typically think about them in architecture, being either a rigid condition, frozen frame, or an animated condition that's much more two-dimensional and then projected onto a surface. So starting to think about these things in the context of again, an isolated condition. Similarly, in terms of the notion of digital economy, thinking about surfaces in a much different way than we might in terms of the way that digital technique is starting to sort of dictate the way that geometry is generated, in the sense that in the case of this particular example, if we were to draw a line and extrude it, that extrusion then creates a surface. And in terms of digital economy, starting to take advantage of these techniques and tools that are available to us to sort of bypass that relationship, in the sense that these two surfaces are single surfaces with minimum face count that utilize multiple texture maps to actually generate the depth or the implied depth of the surface, while retaining physical sort of textural accuracy as the texture moves up and down each ridge here. So that's taking a little bit of the technique from the gaming industry and the film industry in terms of how they're using high-level, high-resolution textures and maps to actually start to simulate distortion of surfaces without actually distorting those surfaces, and sort of keeping face counts minimal, and again making sure that everything is high efficiency in terms of a sort of the digital scale. So this and the previous examples, I like to call they're quite cheap in the sense that we're not really bogged down by the amount of surface geometry that's created through these manipulations, and again, which also then benefits the process as you're working with multiple systems or different geometries within the context of a single project or a single file. So there are many benefits to working much more digitally efficiently as well, that then also allow us to play with these things in different conditions, whether they be architectural, artistic, of course, but in this case, using the same exact texture in a much different way or much different context in the case of this sort of horizontal surface that can be experienced. So to get a little bit more in depth with what that means in terms of the real-time context, what I've been looking at specifically is the use of what's called an alembic file type, which is more or less baking in the animation or the animated techniques into physical geometry to then bridge the gap between an animation software and, in this case, the real-time software, which is Unreal Engine. So more or less using these file types back and forth to actually simulate a lot of these geometric distortion or conditions, again, in a real-time context, that I can start to evaluate these things much more fluidly and much more efficiently, because I'm not necessarily relying on render times, etc. And also then seeing how these surfaces and geometries start to actually respond to material changes. In the case that these are custom materials that are generated to articulate the geometry in a much more fluid sense, it sort of highlights the distortion. So in this case, this particular material that I'm mapping onto the sphere is more of a positional shift between color A and color B that references the material or the metallic material of that base surface. And then I have full control over these things in real time to really understand the potential of these things in a built environment, or also the context of a built environment. Of course, being very specific with these things in terms of concept architecturally, of course. And again, the constant question I'm asking myself is really about the reality of these systems, or the sort of implications of these in reality, in the sense that some of these might want to be two-dimensional projections. Some of these might want to be three-dimensional distortions, but it doesn't necessarily have to be one or the other in my mind. It can be both. But there's a lot of work to be done in that context. But at least this starts to get us into a very quick evaluation or a stance to evaluate these things in a much more fluid context. Similarly, thinking about surfaces and geometries as combinations so that they're not necessarily isolated. So dissimilar from the previous object studies that had a very clear relationship between base surface and top surfaces as an architectural context. Here, I'm beginning to map these two elements together, or starting to share attributes across multiple surfaces or multiple elements, to start to distort the relationship between, say, an attached element and the base surface. And again, playing with lighting and atmosphere to really enhance the variability across an individual surface. So moving into a much more specific investigation, what I'm titling Vignette Experiences. So thinking about these things much more in the context of specificity, without necessarily being married to much larger projects, but much more about sort of understanding the potential or the benefit of working in these things in isolation. So these next series of images are not necessarily an architectural investigation. They're more of an investigation on or into materiality given an abstract urban environment, but also the way that visual noise and sort of the everyday real can start to be used in the context of not only architectural representation, but in the way that design is actually sort of investigated across multiple conditions. And in the idea of the vignette is again married to the use of physical-based cameras. So physical-based cameras now become in my workflow very, very significant and very important because of their sort of relationship to the way we perceive space. So this case study, again, is not architecturally specific, but it's very much rooted in an investigation of detail in the everyday, but also, of course, playing with a little bit of architectural intervention in an abstract sense, but much more focusing on these elements that exist in space that we might necessarily overlook most of the time, but actually enhance the feeling of the legibility of these fixed images, or these of course real-time environments. And then focusing in on a much more detailed context, and using the techniques and tools that we have to our disposal to really get a full understanding of how to, again, most efficiently simulate some of these conditions and have a really, really nice control over how these things might have an impact on our design process in the future. For example, how surfaces might age over time. A lot of these things might need a little bit of an investigation depending on what you're working on. But in the case of this particular pipe, it was much more about the sort of simulation of this thing across the time. So not necessarily fixed to an animation, but much more about an implication of time across that object in this sort of implied environment. But beyond that, also the addition or the use of what's called a decal in gaming terms. So the bottom half of this wall is actually a series of images that are projected onto the surface in combination with a base texture. So the base texture is not necessarily going to always be in the forefront or on the foreground, but we can actually start to layer these things up in three-dimensional space interactively to get a much better understanding of how these sort of imperfections start to emerge in the case of this particular study, and sort of give it a much more rooted sense. But the vignette also, for me, deals with, again, architectural conditions that are really specific in terms of interests in pattern, tectonics, materiality, adjacencies, etc. And the vignette in this case, this really short animation actually gives gives a really interesting insight into the way that multiple systems can be sort of overlapped and provide maximum variability while having a really, really clear logic of assembly or sort of relationship in space. So in this case, I'm testing the facade or an enclosure quite generally with an established hierarchy and a combination of elements working in unison, again, for that maximum variation of a single system. And this single system, again, is rooted in an understanding of how architecture or generally construction or constructability works. So looking at pattern more generally, and just seeing how these things are sort of operating in a three-dimensional context. But again, taking advantage of the real-time platform to see how these things work in a given environment and having the ability to change these things and maybe even push back on the design itself. So I tend to look through lenses often in the case of the workflow, even though I don't necessarily design through a single image. I definitely use multiple cameras at multiple times to make sure that certain things are sort of reading as they should in terms of composition, sort of proportion, etc. So thinking about these things in an architectural sense of a projected view is something that I often do in terms of setting up multiple cameras across a given bounding box in terms of top view, side view, front view, left view, back view, etc. But really focusing on, again, proportion, aspect ratios, f-stops. Again, I think all these are factors in explaining an idea very clearly and effectively. But also having a bit of creative freedom in this process to not necessarily take a standard shot or a standard image. Just in the context of these three images, these two are much more understandable in terms of the way that the space is experienced, whereas the one prior is much more abstract in the sense that it sort of lends itself to many, many more questions in terms of how the space is actually experienced. And merging these several techniques or elements together in terms of the animation, the tectonic relationships, the architectural implications of enclosure in sort of an imperfect urban setting is something it's really important to me in terms of how we see the architecture actually relate to its context. And in this case, the fixed image actually allows a bit of ambiguity in the way that the project is experienced, in the sense that we don't necessarily understand where the boundary is. But there's enough information here to actually allow us to understand or sort of simulate for ourselves what that context might be, in terms of where the light comes from, where the steam comes from, where the sort of red light on the left side comes from. All these things are sort of understood as a set, but much more, again, rooted in trying to explain the sort of richness of the project in its context. So as Chandler mentioned, all of this research is, of course, sort of geared towards material speculation as well as a sort of an underpinning for most of the work. And also the way that materials experience. So in the case of this particular image, color and material, or material and lighting have a very clear relationship to one another. And of course, the implication of, or the use of lighting is very specific in the work, even in the way that these surfaces are understood as three-dimensional conditions. But material specificity and, again, sort of speculation really stems from a control of certain geometric conditions within any given architectural condition. So in the case of these two images, these are sort of detail shots of custom textures that I've developed that we'll talk a little bit about in the workshop as well. But again, going back to the idea of digital efficiency or digital economy, working with single surfaces to then generate really clear relationships between sort of base layer and top layer, again, all within the context of a single texture, to sort of maximize the efficiency and the potency of that texture without having to, say, layer things in Photoshop or really understand how these things work in a real context. So it's more of a simulation that can really amplify or speed up the design process in the case of these two images. But also in terms of custom materials in digital software. So in this case, this particular material or this particular animation or facade study is interactively changed with a series of parameters or sliders that actually allow me to see how the surface then reacts to projected lights or lines as a series of drawings on these dynamic surfaces as an evaluation tool. And seeing how they work across different surfaces is really important in this case, given that the specificity of this particular investigation is more about the combination of, you can see the surfaces below where it's an abstraction or a subtraction of these perforated elements, but also using the sort of negative masks to actually use them as colors or illumination, more or less emissive material, and the combination of both of those and sort of playing up a pattern and things of that nature as well. And then, of course, controlling the atmosphere, the lighting qualities, the texture at multiple scales, the variety of textures in this case, even playing with the notion that concrete doesn't necessarily have to be rigid. It can be thought of as something that's much more fluid, because concrete is actually a fluid material. It sets rigidly. Perforated elements can start to become fluid as well, in the sense that the distortion of the negative or the distortion of the whole, the cut, can actually start to be accentuated with the base geometry being distorted as well. So similarly to the vignette discussion, change of view is also, again, really important for me. So this is the same project that I showed just a minute ago with the animated elements on the facade in the context of that really zoomed in shot. But changing the view, again, this sort of relates to the way that multiple cameras are used in any given investigation or project for me, and understanding these things through a lens at multiple lens lengths to really get a really good understanding of how these things are experienced across the different regions of the project. And then starting to actually use the software itself to again, make really quick decisions in the context of any given study. And again, these are not necessarily specific architectural projects, but the ideas are consistent within that, where all these cameras that I'm shifting back and forth from to are fixed in space. And then, of course, I have the variability or the ability to change the parameters of each camera to really understand what the implications of a given facade panel might be at a given moment, given that the light quality is very fixed or might be fixed, but also the way that these things can start to be changed in that context based on these parameters that I'm setting for myself, but also having a little bit of freedom with the way that shadows are projected, etc. And then lastly, speculation in practice. So being a little bit more specific in terms of the architectural realm, again, trying to synthesize for you all the conceptual notions with how we're dealing with these things in practice. So in most of these images, these are comprehensive architectural projects that have very specific requirements for of course, material investigation, tectonic relationships, all the things that we've talked about prior, but also in this case, a very clear relationship to an existing site or an existing condition. that all is sort of necessary to synthesize the design. But in the case of these particular images, the ideas are much more consistent in the sense that they are still thought of as vignettes. Vignettes meaning that they're focused regions of the project as opposed to showing the entire project at once, sort of all inclusive. These are much more, I see these much more as rich conditions that can be extracted from and used in concept in other projects as well, or starting to think about these things as again snapshots of ideas, even though they exist within the context of a project that's been designed, and starting to play with these things as really flexible conditions that might lead us somewhere else that we're not necessarily thinking about at the moment. But again, the context of these images again are sort of fixed moments in any given project. These fixed moments are thought of as again a snapshot that could be used as part of the design process, or maybe not. Maybe it's just an example of how these spaces are actually experienced without necessarily having to use this as a way to sort of change the way that the spaces feel. So as a really interesting case study, a colleague of mine, Marty Summers, and I, we designed and built an outdoor dining space. And part of this process was really interesting to see in the sense that we can simulate or start to simulate all these conditions as real tangible conditions prior to actually understanding how these things work on site. And the idea is that we have a full understanding, comprehensive understanding of how these systems or material systems actually have to work with one another prior to actually getting on site and building these things. So a lot of the material research and the investigation prior actually aids quite dramatically in the actual delivery of a project, considering we understand much more about how these things work because we're able to simulate a lot of these in the design process. Similarly, even how the relationship between the landscape and materiality, and the way the materiality might start to just deform over time or start to weather over time. So starting to think about actually that simulation as part of the way that we present the work, as opposed to it always being pristine and never really always sort of out of the box. A lot of these things are personally important to me, the way that we can start to manipulate textures and materials in their context, even the slight imperfections underneath the siding here, the dimpling of the metal. All these things are quite important in the sort of understanding of how these things are, of course, built in the real world, but also then sort of how they're going to age in that context. And then within this particular case study, the idea of actually walking around a model that's been geared towards the way we actually walk through space. The idea that animation has to be fly-through, to me, is always a bit of a red flag. So I've been investigating quite heavily the subtlety of motion within any given sort of walkthrough animation, with the goal of getting a much more clean and clear understanding of the space, but also having a little bit of a cinematic quality to it that really starts to enhance the architecture and enhances the sort of atmosphere and aura of the project. So in this case, again, dealing with particle systems to sort of play with the weather conditions, that has a really clear impact on the way that the architecture is legible, or the architecture is read. In the case of this project, it's a little bit cold. Well, looking at the iterations of the variety of different conditions, not only in terms of atmosphere and lighting, that help challenge the way that the design decisions are being made, but material relationships, relationships to landscape, how people walk through the space, what are the implications of a highly reflective material versus a really matte material, etc., all have a pretty significant impact on the way these things are pushed forward in terms of an idea. And again, sort of coming back to the vignette again. I mean, again, these are non-sequential really, but the the difference between the image on the left, the image in the middle, and the image on the right, pretty significant in the sense that there's a really clear understanding of a fixed condition in time against it being something that you're experiencing in real time that's actually now connecting you directly to the architecture. Is something that I'm constantly exploring and hoping to get a little bit more into in the future. Again, really just to help root the experience a little bit more, as opposed to it always being sort of at arm's length. And then, of course, looking a little bit more in detail in terms of those material relationships, the adjacencies, the specificity, etc. So I will leave it here, and I want to thank you all for joining me this evening. I'm quite excited to see where all this goes and how you all respond in the workshop. I'm really eager to work with you all, and I would be happy to answer any questions that you might have. So thank you all.
Yeah, again, so if anyone has any questions, drop it into the Q&A at the bottom. Brian, you covered a lot of territory, right? And quite a bit of amazing visuals to look at that really draw us in. I guess, maybe as a starting point until we get a few questions, like, what kind of brought you to being focused on, at times kind of hyper real, as a way of exploring design?
Sure. Yeah, I think I've always had a bit of a, or I've always had the passion to try to find the most efficient way to get to that without necessarily leaving behind all of the conceptual richness in a project. So I think with the tools that we have available to us and the speed with which the technology is allowing us to work within that context, it becomes much more clear of a path to get into that realm without necessarily losing all of the ideas or the concepts involved. Again, not to say that these are, or I suppose I should say that my ambition is not necessarily realism, but it's more about the understanding of space and accuracy and comprehension, as opposed to it being a real sort of photorealism that's driving the work. I'd say it's the opposite way, where I'm taking advantage of techniques and tools that allow a little bit of that realism to show up without necessarily losing the ideas in that translation.
Yeah, I mean, I think the realistic qualities give it enough familiarity, right? That we can really start to associate kind of a kind of tactile quality. And I'm not just kind of referring to the last series, of which is more architectural, where we have a sense of scale. But even the other kind of earlier work where we have no clue what scale it is, right? There isn't really a scale, and it's fine. It actually makes it a little bit more interesting to not know, right? That you're kind of speculating on in just how we read that. Sometimes there's clues of maybe how one material kind of panel kind of ends, but even then, you kind of focus on kind of joints and continuity or discontinuity, and just the kind of relationship of one material to the next, or one kind of object to the next. It provides an interesting way of yeah, kind of understanding pattern and geometry repetition.
Mhm.
All right, so I've got a question here from Hans Tursak, who's visiting faculty. Here I said, "Hi Brian, I love the work. Do physical models and prototypes fit into your animation workflows? There was a jump from animation to one-to-one architecture. How do you work in between with physical materials?"
Hi, Hans. Thanks for the question. So it's interesting you ask, because I do absolutely want to investigate physical sort of materialization of these animated conditions. In the case of the latter part of the presentation, where the work does become much more tangible in terms of the architecture, for this particular project, I built a half scale model out of 3/4 ply, for example. So a lot of these design decisions are being made in tandem, not necessarily in isolation in terms of the way that they're actually materially or tectonically relating. And in this case, the investigation then led itself to a different space in terms of material and atmosphere, etc. So I think the goal, of course, would be to take a lot of the early studies in terms of the animation and start to think about how we can relate animation to physical, whether it's through projection or it's actual physical relationships of actuators and things of that nature. But I'm not necessarily sure how that's gonna go. But there is a really strong desire for me to keep things physical as well, as opposed to just keeping them purely digital.
Yeah, and you also have more architectural built projects, right?
Mhm.
I know the kind of focus of your lecture was more on the experimentation that you're doing. I know you mentioned the one project of the restaurant with the kind of wood screen, which was actualized, and a few other investigations. So I've got a question here from Constance Vale. The interest in blurring architectonic and cinematic realms is really evident in your work. Do you have interest in leaning more into the cinematic side? Do you see yourself making a film in the future? And does that stray too far from your architectural interests?
Thanks, Constance. It's a great question. I would love to make film in the distant future. I think that'd be a really strong desire of mine. I think that inherently the two are beginning to connect a little bit more clearly for me than I thought they would in the beginning, in the sense that architecture and design, of course, there's a lot of similarities, I think, in the way that, now, of course, I'm not a filmmaker and I wouldn't dare to guess what film is like, but the attention to detail and sort of the specificity of form and space, lighting, etc., are all consistent within an architectural realm. And I think in that sense, a lot of the work that I've shown today is starting to lean towards ideas of cinematography without necessarily being cinema or having a really strong legibility of cinematography, but more or less taking the techniques that I've seen or I've investigated myself, and starting to use those now in an architectural realm. Again, whether it's in the way that the work is presented in a two-dimensional context or a three-dimensional context, but I've even really sort of looked at how ILM is dealing with Unreal Engine and the way that they're building essentially interactive HDRI environments for film sets, and the way that that's actually affecting the way that light is projected into a space, and how that might actually push back on the way that architecture is shown or presented. Could be a really interesting avenue that I'd love to explore, but I would hope that that's something that I could get into eventually.
Yeah, well, I mean, it kind of reminds me of Joseph Kaczynski, right, with Oblivion, the film, right, and you know, you know, trained as an architect, but now a filmmaker. I think maybe one interesting thing to think of this is how kind of transdisciplinary knowledge, right? You can take knowledge from one discipline and have it kind of cross over and inform other disciplines and vice versa. And you know, many ways it's the kind of the dream of what we're trying to accomplish here with the Fox Fridays and at Sam Fox School, right, being architecture museum, you know, many disciplines, and a lot of knowledge, and it really seems like your kind of work is really tying across multiple fields in interesting ways, and you know, kind of producing an interesting conversation about blurring the boundaries between disciplines. So it seems really timely.
Yeah, I kind of wanted to follow up. Do we have time for one more question?
Sure, sure.
Yeah, I think, you know, following up on Constance's question about, you know, this relationship between architecture as like a passive or an active experience, and cinema as a passive experience that we sort of watch. I really appreciated your the way you talked about motion, not as just like adding this layer of the fly through as like an extra thing, but thinking about the balance between how moving through something also and the movement of the space itself are represented. And I also think the way that you're, you know, playing in a very speculative material space, but then also thinking about, you know, you talked about the dining space, that you're starting to kind of balance those things. Not to put this in what might be like a cliche topic, but I'm curious about how you think some of this study relates to a future Web3 occupation of like space that is like thinking about some of these materials and experiences and the moving surfaces with projections on them. I could see like real life in what we are speculating may come soon, and so I'm curious what your thoughts on that in that space are.
Yeah, I haven't given it much, Jonathan, to be frank. I think my gut reaction is that it's a matter of resources at this point. I mean, I'm not really sure, you know, to what extent it's possible without sort of natural intervention. So in the sense of, or in the case of this animation, so the idea, or most of the distortion that I'm actually working with in terms of the way that these geometries are moving are quite simple in their relationship to axes. So I'm not sure that it's necessarily something that would be, it most certainly would not be groundbreaking in the way that these would be rationalized into a physical form that's then interactive. Where I think there is a bit of opportunity or a bit of benefit to the combination of those two things, where one sort of gets there are moments of physical with moments of projected. And I don't know where that line exists at the moment, because I think there's a bit of an opportunity for both, even in the way that the material has the opportunity to distort over time, or even just in position. Because in that sense, you know, some materials already start to actually change their legibility as they're stretched or as they're pushed or compressed or things like that. But it doesn't necessarily mean that would be a direct translation to something like this. So I think in this case, I'm still using these as methods to iterate through. Even in the case of this small shot here, these are just different variations of the same system at any given moment that I can then say, this combination has an interesting condition. how can I then develop that a little bit further in a fixed condition in terms of architecture, as opposed to it being, it has to be animated or it has to be tectonic, or not tectonic, it has to be interactive. So that's where I've tried to position the work today, just in terms of the flexibility of it in an iterative context. But ideally, it would become much more physical and tangible as it's being designed through an animated condition.
Sure.
All right, cool. I think that would be a good place to wrap up. Yeah, we definitely look forward to seeing the work that comes out of the workshop tomorrow. All right, so
Thank you all.
yep,
Appreciate
thank
it.
you.
Thanks
Yeah.
for being here, Ryan.
Thank you guys.